So 4.4 part 2. So we're going to talk about reference angles. So two things that we have to keep in mind about our reference angles is that they are always going to be acute. What does acute mean? Less than 90. And that they are always positive. So reference angles are going to be like a smaller version of our actual angle that we have, so we can use them to solve our trig functions. So it says let theta be an angle in standard position if its reference angle is the acute angle. This is the symbol for reference angle, so it'll be theta with a little prime on it. So it's got that extra tick mark. Formed by the terminal side of theta and the horizontal axis. So if I had an angle here with my initial side and my terminal side, so this angle would be from here to here. It's greater than 90. It falls in the second quadrant. To find its reference angle, we take the terminal side and the horizontal axis. So this would be our reference angle. So if we were turning this into a triangle to help us solve for whatever, we would drop the third side to the horizontal axis. So that third side always gets dropped to the horizontal axis. If I had another one here, so let's say my reference angle ended in the fourth quadrant here. Our reference angle would be formed with the terminal side and the horizontal axis. So our reference angle would be this little angle here. So our reference angle is always going to be acute, so it's less than 90, and positive. So reference angle, you can think about it, is the distance from the horizontal axis. So it's always formed by the terminal side and the horizontal axis. So depending on which quadrant we're in, we have a different formula to help us find our reference angle. So to kind of put all three of these together in one picture, if my theta is in the first quadrant, my reference angle is going to be the same thing, because everything in the first quadrant is going to be acute and positive already. If we are in the second quadrant, our reference angle is going to be 180 minus theta. If we're in the third quadrant, our reference angle is going to be theta minus 180. And then if we're in the fourth quadrant, our reference angle is going to be 360 minus theta. So depending on which quadrant you're in, we have a different formula for the reference angle. Now, if you happen to use the wrong formula, let's say your theta was in quadrant 2 and you use theta minus 180, it's not going to give you an answer that's acute and positive. So if you use the wrong formula, your answer won't be acute and positive, so you know that you did something wrong. So always when you're finding a reference angle, think, is my answer acute and positive? Then that way you can check your work. Now this is for when we're in degrees. We have the same thing for radians, but remember 180 in radians is just pi. So if you wanted to do pi minus theta. But it's a little bit harder when we're in radians to figure out which quadrant we're in. So you can always convert it to degrees, but don't forget to convert back. If your angle's in radians, you want your reference angle to be in radians too. Your reference angle is just going to be a smaller version of your angle. So if your angle's in radians, your reference angle needs to be in radians too. So let's look at example A. We want to find the reference angle for theta. So 300 degrees would be in which quadrant? Quadrant 4. How would we find the reference angle? What formula do we use when we're in quadrant 4? 360 minus theta. So we would do 360 minus 300, and what do we get? 60 degrees. Don't forget the degree symbol. So our reference angle would be 60 degrees. For C, we want to do the same thing. However, the formulas don't work if it's negative. You can't just plug it right in, do your 180 minus your theta if you have a negative number. Your number has to be somewhere in between 0 and 360 in order to just plug it into the formulas. So what do you think I could do to make this negative 135 be in between 0 and 360? Add 360. We want to find a coterminal angle to this first. So I'm going to add 360. What do we get when we add 360? 225. Perfect. What quadrant is 225 degrees in? The third quadrant. What formula do we use when we're in the third quadrant? Theta minus 180. So we'd do 225 minus 180. What's 225 minus 180? 45. So our reference angle would be 45 degrees. So again, we're finding the reference angle. It's a little bit harder to tell what quadrant we're in when we are given radians. So we can convert this, find our reference angle, and then convert it back. So what would I do to convert this to degrees? Awesome. Multiply by 180 over pi. So then the pi's will cancel. 3 goes into 180 60 times. So we have 2 times 60, which would be 120 degrees. What quadrant is 120 degrees in? Quadrant 2. Perfect. What formula do we use when we're in quadrant 2? 180 minus theta. So we would do 180 minus 120. What's 180 minus 120? 60. Now this is kind of our answer, but since our question was in radians, our reference angle also has to be in radians. So we need to convert it back. So what would I multiply by to convert it back? Pi over 180. So we get 60 pi over 180, which would simplify to what? Awesome, pi over 3. So our reference angle would be pi over 3. Any questions here? Let's do B. So first let's convert it to figure out what quadrant we're in. So we're going to multiply by 180 over pi. The pi's cancel, and 6 goes into 180 30 times. So we have 30 times 23. 30 times 23 would be 690 degrees. Now 690 degrees is more than 360, so our formulas don't work to find our reference angle. How could we find a smaller version of this? Find a coterminal angle. We're going to subtract 360. So when I subtract 360, I get 330. What quadrant is 330 degrees in? What formula do we use for the fourth quadrant? 360 minus theta. So 360 minus 330 would give us 30 degrees. Is that my answer? What do we have to do next? We got to convert it back to radians. Since our question was in radians, for our reference angle, we got to leave our answer in radians too. So we're going to multiply by pi over 180. So we get what? Pi over 6. Perfect. So for your reference angle questions, if your question is in radians, your answer has to be in radians. Remember, your answer is always going to be acute and positive. So if when we find the 30 degrees, or that part, just double check. Is this acute and positive? Yes. So then convert it back. So we can use our reference angles to help us solve trig functions. So if we were given an angle theta that was greater than 90 here, we couldn't form a right triangle with this angle, but we can form a right triangle with our reference angle. So we'd use the terminal side and our x-axis, and we would just find the trig functions of our reference angle. Now the only difference is, because obviously theta and theta prime are different angles, The only difference is going to be the sign of it. So you have to keep in mind your all students take calculus. So you can find the trig function of your reference angle. You'll get the same answer, but you have to keep in mind what quadrant you're in because that's going to affect the sign of your answer. So if we were in the second quadrant, if our theta puts us in the second quadrant, then we know that sine and its reciprocal are the only things that are positive. Everything else will be negative. So just keep that in mind. So it says that sine of theta and the reference angle sine of theta prime, so sine of the reference angle, are equal except possibly in its sign, so whether it's positive or negative. So the same is true for tangent of theta and tangent of the reference angle. So they're going to be the same value except possibly the sign of it. So you have to check your all students take calculus. So when we're evaluating trig functions at any angle, to find a trig function of any angle, first you want to determine the function value of the associated reference angle. So you want to find the reference angle first. And then it says, depending on the quadrant which theta lies, affix the appropriate sign to the function value. So then you want to check your all students take calculus. Let's find the reference angle. Find the trig function of it. So you're going to determine the function. Then you want to check the sign. So let's do our last example. Let's look at A. We have cosine of 4 pi over 3. Now 4 pi over 3 is on our unit circle, but for the quiz, you're only going to be given the first quadrant of the unit circle. So this part of it is not going to be here. Let me erase it so we can get a... So you're only going to be given the first quadrant, so you have to use your reference angles. So it'll look like this on the quiz. So cosine of 4 pi over 3. Let's first figure out where 4 pi over 3 is. How can I figure out what quadrant 4 pi over 3 is going to be in? What can we do first? Change it to degrees. So let's multiply by 180 over pi. The pi's will cancel. 3 goes into 180 60 times. And 4 times 60 is what? 240. So we're looking for the cosine of 240 degrees. Now 240 is not in the first quadrant of our reference angle here, or of our unit circle. So we have to find the reference angle. How would I find the reference angle? What quadrant is 240 in? It's in the third quadrant. What formula do we use in the third quadrant? Theta minus 180. Perfect. So we would do 240 minus 180. What do we get? 60. So we're looking for the cosine of 60. Now when you're evaluating here, you can convert it back, but our unit circle that we're given has both radians and degrees. So we can just leave it as 60 because this isn't our final answer. We're going to go look at our unit circle to find the final answer. So we're looking here at cosine of 60. Cosine tells us we look at what? The x or the y? The x. So our x value is what? 1/2. So this would be 1/2. But the last thing we have to do is figure out the sign of our answer. So we have all students take calculus. If we're in the third quadrant, what's positive? Tangent and its reciprocal. So what would cosine be in the third quadrant? Negative. So this is negative 1/2. Because 240 is in the third quadrant, right? In the third quadrant, only tangent and its reciprocal are positive. So tangent and cotangent. Everything else is negative in the third quadrant. So because our original angle is 240 degrees, and that puts us in the third quadrant, when we find the cosine of it, cosine is negative in the third quadrant. So our answer has to be negative. So our answer is negative 1/2. So the first thing we want to do is find the reference angle. Second thing we do is evaluate the trig function. And then the third thing we do is evaluate the sign, or figure out what sign we are. All students take calculus. Find the sign. First thing we want to do for B is find the reference angle. But negative 210 is not, it's negative. It's not in between 0 and 360. So what would we need to do to start? Add 360, perfect. So let's add 360. What do we get when we add 360? $150, perfect. So what quadrant would 150 be in? The second quadrant. What formula do we use to find our reference angle for the second quadrant? 180 minus theta, perfect. So 180 minus theta in the second quadrant. So we're going to do 180 minus 150. We get 30. So we're looking for the tangent of 30 degrees. So let's go to our unit circle. We're going to go to 30 degrees, which is here. Tangent is what over what? Y over x. Tangent is y over x. So the tangent of 30 would be, what's our y? 1/2 over x, which is square root 3 over 2. What do we do when we have a fraction and a fraction? Keep, change, flip. We're going to keep the top, change to multiplication. We're going to flip the bottom to 2 over square root 3. So the 2's will cancel, so we get 1 over square root 3, but we can't leave our answer like this. What do we have to do? Rationalize. So multiply the top and the bottom by square root 3. We get square root 3 over 3. But the last thing that we have to do is check the sign. We need to know, is this positive or negative? So if we have all students take calculus, we're in the second quadrant. What's positive in the second quadrant? Sine and its reciprocal. So what do we know that tangent is in the second quadrant? Negative. So our answer would be negative. So we're using the same rules that we were doing before. So sine is the y, cosine is the x, and then tangent is y over x. So we're kind of putting together what we have in the last couple sections all in one. All right, let's do C. First, what should we do? Change it to degrees. So we're going to multiply by 180 over pi. The pi's will cancel. 4 goes into 180. How many times? 45 times. And then 45 times 11 would be 495. So we're looking for the cosecant of 495 degrees. What should we do next? Minus 360, because 495 is more than one way around the circle. So we can't use our formulas here because it's more than 360, so we want to subtract 360. So cosecant, when we subtract 360, we get 135. So cosecant of 135, still not on the part of the unit circle we have, so we need to find our reference angle. How would we find our reference angle? What quadrant is 135 in? the second quadrant. What formula do we use in the second quadrant? 180 minus theta. So we do 180 minus 135. So we're actually looking for the cosecant of 45. So we're going to go to 45 on our unit circle here. Cosecant is what over what? 1 over y. It's the reciprocal of sine. So 1 over y on our unit circle here would be 1 over square root 2 over 2. What do we do when we have a fraction and a fraction? Keep, change, flip. Keep the top, change to multiplication. We're going to flip the bottom to 2 over square root 2. So we get 2 over square root 2, but we have to rationalize, so multiply the top and the bottom by square root 2. We get 2 square root 2 over 2. Can we simplify this anymore? The 2's cancel, so what are we left with? Square root 2. Now we need to figure out, is this positive or negative in the second quadrant? We have all students take calculus. Sine and its reciprocal are positive in the second quadrant. So what would cosecant be? Positive. So square root 2 is positive.